Okay, so I'm hoping most of today should be review. Today we gotta start talking about ratios and proportions. Ratios we've messed with. A ratio is just a fraction. A ratio is just a comparison of two numbers by division, which is all a fraction is. So 5 over 2, 4 over 7. That's a comparison of two numbers using division. That's all a ratio is taking two numbers and basically just dividing them. All right, now how do we use them? We've done one like this before, dealing with angle measures. Can't get it all to fit. Ratio of the side lengths of a quadrilateral is 2, 3, 5, 6. Again, these are not the actual side lengths, it's the ratio of the side lengths. And telling the perimeter is 85 feet. So all they did was that they took the actual side lengths, divided them all by the same number, and they basically simplified it, divided everything by that same common factor, and now I have 2, 3, 5, and 7. So I got to figure out what that common factor is. What did they divide each number by? Well, I can just call it x. That's what I'm trying to figure out. So 2 times x is the actual side length. 3 times x is this actual side length. 5 times x is that side length. And 7 times x is that side. Again, it's the same number that they divided all the sides by. So if I draw my shape, it looks something like this. It's a quadrilateral. Again, that side is 5x, 2x, 3x, and 7x. So if I add them all up, 2x plus 3x plus 5x plus 7x, well, they've told me the perimeter is 85. So if I add all these, it should equal to 85. So then 17x equals 85, x equals 5, and it asks me for the longest side. Well, the longest side has to be the 7x right here. But we just solved for x. If x is 5, my longest side has to be 7 times 5, which is 35. Okay? What is a proportion? A proportion is just an equation that states that two ratios are equal. So again, a ratio is a fraction. It's comparing two numbers using division. All a proportion is taking two ratios and setting them equal to each other. For example, 2 over 4 equals 1 over 2. This is a proportion. We're setting two ratios equal to each other. More on that. All right, extremes. So if I've got a proportion, if I have A over B equals C over D, the A and the D in this position, we just call those the extremes. So the A and the D, we call those the extremes if it's set up like this. Okay, the mean, so again, I've got to set up the same. It's still A over B equals C over D. We call the B and the C, these two positions, we call those the means. All right, and cross products. So if I have, again, A over B equals C over D. Again, I know y'all did this in Algebra 1, probably maybe, I don't know, 7th grade, 8th grade. When you do cross products, I take the A and the D, I multiply these two together, and then I multiply the B and the C, I multiply those two together. So it's the product of the means, which is the B and the C, so B times C gives me BC, and the product of the extremes, which is A times D. And then what we need to know is that when I do that, it's important that A times D will equal to B times C. So I cross multiply. I take the A times the D, and I take the B times the C, and they have to be equal to each other. All right? They tell us here. So we're told that A over B equals C over D, which again tells me A times D equals B times C. And we're told that neither B and D are equal to 0. So on this one, they give us A over C, and they want to know what that has to be equal to. Well, again, I already know from here that A times D has to equal B times C. So what must I put in this one? Well, A times what has to equal C times what? Again, going back up here, look at this. A times D equals B times C. So they rearranged the letters, but if that's an A, that has to be the D, so I can still get my A times D, and I still get my B times C. So it works out the same. This one said A times D equals B times C, so does this. A times D equals B times C. It's the same thing. And again, they did it here too. Okay, they flipped the order around, so now we have B over D. Well, B times C still equals D times A, which is what we still have over here. and they did it again on number C, or letter C. A times D still equals B times C, which is still what we had at the very beginning. They do mix it up a little bit. Now notice they had I still have an A here, and I still have a C over the D. So what did they do to the A? They just multiplied it by 2, which means all I got to do is multiply this B times 2, and it'll still hold. Because this still says 2 times AD equals 2 times BC, which is still true. And over here, A plus B over B, all they did was add B to the A, so all we have to do here is add the D to the C. If this is any part confusing, I've got plenty more examples of these in class. Okay, solving the proportion. This again, I know you've done these. I know you have. All we're doing is cross multiplying. So we're taking 5 times 63, and we're doing 45 times y, and we're setting them equal to each other. So 5 times 63 is 315. 45 times y is just 45y. Divide both sides by 45, and you get y is equal to 7. This one, I did it a few times, so unless I messed up, which there's a good possibility that I did, I keep getting a fraction for an answer, which doesn't mean it's wrong. Just usually in the notes, they try to make them look a little better. They don't try to intimidate you guys right there at the beginning. So if you find my mistake, let me know in class. So again, I'm still going to cross multiply it. X plus 3 times x plus 2 has to be equal to x minus 5 times x plus 4. So that's all I did. So x plus 3 times x plus 2 equals x minus 5 times x plus 4. I did my double distribution. I did some algebra 1. And I now have x squared plus 2x plus 3x plus 6 on this side. And over here I have x squared plus 4x minus 5x minus 20. Well, I've got x squared on both sides. I can subtract x squared from both sides. And then I can combine my like terms. 2x plus 3x is 5x. And 4x minus 5x is minus x. I can now add x to both sides, and I get 6x plus 6 equals negative 20. I can now subtract 6 from both sides, and I get 6x equals negative 26. Divide both sides by 6, and I get x equals negative 13 over 3. Again, which is a really ugly number, which is why I was convinced that I had messed up, but that's what I get. Again, if you can find my mistake, let me know in class, because I tried, I couldn't find it. Alright, another example. So here we go, this one. Again, I got to cross multiply. I got to do 2y times 4y. That has to equal 9 times 8. So 2y times 4y is 8y squared. 9 times 8 is 72. So I have 8y squared equals 72. Divide both sides by 8, and you get y squared is equal to 9. So then y has to be equal to 3. Of course, negative 3 would also work as well. Alright. I have x plus 2 over 6 equals 24 over x plus 2. I can cross multiply. So I got to do x plus 2 times x plus 2, which is just x plus 2 squared, equals 144. Now again, I could sort of stop here. If I'm squaring this number, if I'm squaring x plus 2 and I'm getting 144, then what does x plus 2 have to be equal to? Think about that for a second. I'm going to go ahead and work this out. But if I'm squaring x plus 2 and getting 144, what does x plus 2 have to be equal to? And that's a shorter way. That's the way I would do it, but I'm going to go in and work this out. Okay, so if I square x plus 2, I get x squared plus 4x plus 4 equals 144. I subtract 144 from both sides, and I get x squared plus 4x minus 140 is equal to 0. So now I factor this, and I get x plus 4 and x minus 10. So then x has to be equal to 10 or negative 14, which is what I would have got up here had I just set x plus 2 equal to 12. Alright, these are good problems. I don't know if I can get the whole thing okay. The library is being expanded, and the new wing's length is to be 50 feet greater than the width. So when they expand this library, the length is going to be 50 feet greater than the width. Okay, and then I have a scale model. I have a smaller, like a floor plan, some blueprints, the smaller version, small scale of my library. And that shows the width to be 22 inches and the length to be 27 inches. So I'm going to draw both. Okay, so here's my model. Here's my scale model. Here's the blueprints, which shows my library to be 22 inches wide and 27 inches long. That's what it tells me. It's 22 by 27. Okay, and here's my actual library. I don't know my side lengths, but I do know that if my width is x, then my length is 50 feet longer, greater, so it has to be x plus 50. So let's just study this picture and see where that comes from. Again, this is just the blueprint. It's 22 inches wide by 27 inches long. And then the actual library, all I know is that the length is 50 feet longer than the width. So blueprint and actual library right here. So now, several different ways to go here to set up your equation. This is how I always do it. And if you like another way, you're more than welcome to do another way, but this is the way I like to do it. I like to take the model and put it over the real. So I'm going to take the width of the model, which is 22, and I'm going to put it over the width of the real, which is x. So width of the model, which is 22, over the width of the real, which is x. Then I set that equal to the length of the model over the length of the real. So length of the model over length of the real. So again, all I did was I took the width of the model and I put it over the width of the real. And I set that equal to the length of the model over the length of the real. So now I have a cross multiplication problem to solve for x. So if I do that, I get 27x. I got to do 27 times x. That gives me 27x. And then 22 times x plus 50 gives me 22x plus 1100. Subtract 22x from both sides, and I get 5x equals 1100. So then x has to equal to 220. So now if x equals 220, that's my x, that's my width right here. So my width is 220, and my length has to be 50 greater than that, which is 270. Alright, ratio of the interior angle measures of a convex pentagon. So it's 2, 2, 3, 5. Again, these are not the actual angle measures. They took all the actual angle measures and they divided them by the same number. So this angle is not actually 2, it's 2x. This angle is not 2, it's 2x. And that's 3x, 5x, and 6x. Okay? So now, if it's a pentagon, what does my interior sum, my interior angle sum need to be? Again, I go back to my formula. It's got 5 sides. 5 minus 2 times 180 is 540 degrees. So I know if I add up all my interior angles, it has to equal 540 degrees. So then that's what I do. I take 2x plus 2x plus 3x plus 5x plus 6x, these 5 angles, I add them all up, but they have to equal to 540 degrees. So then 18x equals 540 degrees. So then x equals 30. And it asks me to find the measure of the largest angle. Well, my largest angle is 6x. 6 times 30, 180 degrees. That's all I got. Please come to class prepared and ready to go.